Okay, we're going to do part C the same way that we did part A and B. That is, we are going to first find the derivative of y with respect to x by differentiating both sides of this hyperbola equation with respect to x. When I do that, I'll get a 16x minus an 8y times the derivative of the y, which is a dy dx, and on the other side I'll get a 0. If I isolate dy dx, I'll need to move the 16x to the other side, which will make it negative, and then I need to divide by the negative 8y. So we end up with a 2x over a y when it is simplified. So the goal is to find the second derivative at a point. So in order to get the second derivative, I need to differentiate dy dx again. So on the left, I will get the second derivative of y with respect to x, and on the other side, I'll need to perform the quotient rule. So I'll have low d high minus high d low. The derivative of the low is a dy dx over a low squared. Again, like I did in part A and B, I will replace dy dx with what it equals. So I'll have a 2y minus a 2x times a 2x over y, and that's divided by y squared. Now remember, this is a complex fraction, so to fix it, we need a common denominator on the top, and then I need to recall that dividing by a y squared is the same as multiplying by a 1 over y squared. So on the top, I'll have a 2y squared minus a 4x squared, and on the bottom, I will have a y cubed. Now let's look carefully at what we have here. This 2y squared minus 4x squared is actually 1/4 of this one up here. So I'm going to factor out a half and a negative, and we can see that we would get an 8x squared minus a 4y squared, which in turn is that 64. So negative 1/2 of the 64 gives me a negative 32 over a y cubed. So now if I want to evaluate that at the specific point, which is 4, negative 4, then I will have a negative 32 over the y coordinate cubed, which is a negative 64, and I end up with 1/2.